Hello and welcome back to the CCNA journey with me, Ryan. And in this video, we're going to start the second section for the CCNA, which is the network access, as we finished all of the network fundamentals that can be found in the previous 20 or so videos. And the first section of the network access will be VLANs. So in this video, we're going to go over VLANs. What is a VLAN? Why do we use it? What benefits it gives us? Why is it needed, etc. And then just to sort of finish off, for those who don't know, you can contact me here on YouTube, LinkedIn, Facebook, or Twitter. So before we actually dive into VLANs and all their glory, we first need to understand why we need VLANs. Up to this point throughout the course, we've discussed the OSI model, subnetting, we've talked about switching and the ARC process, broadcast domains. At this point, we need to bring together everything we've learned thus far to really help us understand VLANs. First, we'll have a discussion around why we need VLANs and what problems do they solve, and then we're going to have a look at actually implementing VLANs. Starting with why do we need VLANs, let's go through the list I have put together. Each department connects to their own switch, and if they have their own switch, it means they require more hardware. So at the moment, let's say we have two departments here. We have sales and we have the IT department. Let's say that sales live on 192.168.0.0/24 and the IT department lives on 192.168.1.0/24. These are completely different subnets. If something, let's say for example, PCA wants to communicate with another PC in the IT department, let's say PCF, it will need to actually do the binary AND calculation against its IP address. Notice that 192.168.1 is in a different subnet, and in turn communicate with the default gateway, which in this case, let's say it's this router. So communication will have to go up to the router and back down. Now the beauty of this is because the router is involved, we can implement things like ACLs, so access control list, to control who can speak to who, and we have more control over our routing. What it also means is we have individual broadcast domains. So if, let's say, PCB sends out a ARP, remember the address resolution protocol, to the switch, and the switch broadcasts that out of all of its interfaces, none of that traffic interferes with the IT department, because remember, routers stop broadcast traffic. So we have individual departments connecting to individual switches, but the downside to that is they obviously need their own individual hardware in order to achieve this. So other challenges is the physical location and planning. For example, let's say we have our sales department again, and this time we have a marketing department. In the marketing department, we have Joe, and in the sales department, we have Kelly. Both of these departments are in completely different subnets. Let's say the sales are in 172.16.10.0/24, and the marketing is in 172.16.11.0/24. Off the back of the marketing, we have the marketing server, and that sits inside the same subnet. So all of the guys and girls that are connected into the marketing department can have direct communication to and from it. Obviously, if sales wanted to speak to marketing, because they're in different subnets, they would need to traverse through a router. But what we would have is some sort of ACL or filtering on the router to ensure that no one else can communicate with devices inside the marketing department unless they're authorized to do so. So this would prevent sales from looking at the marketing files, for example. And that may not be an issue here, but let's say this was the HR department. All of a sudden, we don't want other departments to be able to actually access those files that are actually located inside a different network. But going back to the original design with marketing, Let's say that marketing had a project to work with sales, and Joe decided to move over to the sales department in order to work better alongside Kelly. Well, because now they've actually physically moved, assuming that these switches are not close together and Joe can't have a connection directly back to that switch, Joe has to connect into the sales broadcast domain and in turn the sales subnet. Joe will get an IP address from a different subnet than what she originally would get it from, and because of that there may be limitations with accessing the existing server because of these ACLs that are put up inside the core to increase the security. So we have to put in consideration that as people move to different areas of the business physically, they're going to most likely obtain different IP addressing and in turn have reachability issues, or they've indirectly opened up some kind of vulnerability where moving from one to another subnet is actually giving them access to servers and services they shouldn't necessarily have access for. Okay, so moving on. Next on the list, it's expensive. If we have 50 departments and we have to actually have 50 switches, that's not going to be ideal. What if one department is smaller than another department? For example, we get a great deal on 10 24 port switches, but one department consists of only 4 people. It seems like a very expensive waste of resource to give them their own entire switch just to ensure that they're inside their own subnet. And you might think, well, surely that if everyone has their own switch and everyone connects into their own broadcast domain, then it must be better security. But actually, if we think about it, we actually have less control. It's great for security outside our broadcast domain. So as I said, going back again, if we have our router and we have Department A and Department B and they want to communicate, they have to go through this layer 3 device in order to achieve some kind of communication. And at layer 3, we have a lot more traffic engineering and filtering at our disposal to ensure that we only have the right people talking to the right departments and the right services. But when we actually get down to control within the broadcast domain, this is where it gets a little bit tricky. Like I said, it is possible to do this using things like what we call a VACL, which is a VLAN access list, or we could make simple modifications to the MAC address table directly, but it's not exactly a great way of doing it, and we are limited of what we can do. The other thing is, if someone did move to the switch, remember we moved Joe over, then again, if this particular department, Department B, had a server connected and Joe came along and just plugged directly into that, then they could simply ARP and communicate directly on the link. What we'd want to do is ideally have some sort of control through layer 3 in order to have the ability to say only a subset of IP arrangers are allowed to actually communicate, and they're only allowed to communicate if the traffic is destined for a particular layer 4 port. So we can say, for example, if you're on this list of IPs that I have, you're allowed to telnet to me, you're allowed to SSH to me. And that control comes from having the ability to break outside of our broadcast domain and putting that security on more intelligent devices. Okay, so let's move on to how VLANs help us combat some of the issues that I raised on our previous slide. So what are the features and benefits of VLANs? So the main thing to take away from this is each VLAN is its own broadcast domain. So you can see just down here I have the sales department and the IT department, but notice that they connect into the same physical switch, but we have 2 different VLANs set up. We have VLAN blue and VLAN red. The VLANs are actually given a number, and that's how they're identified. And then alongside of that, you can actually give it a name. So here I've given it VLAN blue, which is 6. Maybe you might name this to the sales VLAN, and VLAN red, which is for the IT. I've done it color coded just so it makes it a bit easier. And they plug into the same physical switch, but each VLAN inside a switch is its own broadcast domain. So that means that if, let's say, Pete inside the sales department sends out a ARP, it would only be flooded on the switch to people inside VLAN 6. It will not go towards any devices in VLAN red. So a good way to think of a VLAN is essentially taking a physical switch and logically separating it into its own broadcast domains. Along with that, it helps us to improve the security. Remember previously when I said that Joe was going to actually move over and speak with Kelly? Well, here we don't have any physical limitations because Joe and Kelly must be relatively close to one another, maybe in the same building because they connect to the same switch. But let's say Joe moves over to sit closer to Kelly. What we can do is we can actually modify the port that she plugs into to the red VLAN, and she would get an IP and have access to all the services that the red VLAN has access to when she moves over. What if, for example, we have Kelly on another switch and we'd have the two switches connected together, and we move Joe over to this switch, then what we can do, depending on the design, is we can also carry over the VLAN. So this link here would actually carry both VLAN blue and VLAN red, and this link is actually called a trunk. But the idea here is now what we have is two broadcast domains spread across two switches. So it's about understanding the separation and the decoupling between the physical and logical elements displayed here. Physically, we have two switches. Logically, we have two broadcast domains. We have red and blue. Both switches know about red and blue, and we can configure red and blue on both switches on any port we so desire. If Joe wanted to communicate with Kelly, because they're on different VLANs, they still need to go up to the router and come back down to be able to communicate to one another. But we do introduce a few things. First of all, we improve the security because VLANs ensures that traffic is routed before it's passed towards another person in a different VLAN. And we also improve the physical and location problem we have by moving the VLAN with the user or creating the VLAN on the destination switch. And you'll find out later on when we get into more details around VLANs that this here, what I've actually demonstrated, relies heavily on the VLAN design. There are things called an end-to-end VLAN design, which is what's shown here. And then we also can have a local VLAN design. And we'll get into VLAN designs a little bit later, but for now, I just want to grasp some of the concepts that we're trying to get across here, which is the VLAN is the broadcast domain. It's no longer tied to the physical switches. And because of that, it gives us the ability to do things we couldn't do before. And it also helps us solve problems we couldn't necessarily solve before. Okay, so the next point, it's some of the terminology that I've been using throughout this video and that you hear throughout the industry with broadcast domain, subnet, and VLAN. So for my video, I've probably been using them interchangeably throughout, but it's important that you take a step back and you thoroughly understand the differences between each and individual part. So we said that a broadcast domain was how far can a frame travel. So here, if this PC sent out an ARP inside the broadcast domain, it would travel to only PCs inside the blue VLAN, because the VLAN is what controls the broadcast domains if configured. If this switch did not support VLANs, then the entire switch is the broadcast domain. Because if any traffic comes into the switch, it could potentially be broadcasted to anyone on the switch. And remember, that's only if VLANs are not created. Now, where the confusion comes into play is it is technically possible to have multiple subnets inside a VLAN, which means in turn they would share a broadcast domain. Now, that is not good practice, but to give you an example of how that might work, let's say that you have a switch, and within this switch you have, let's say, 4 PCs. 2 of these PCs live on 192.168.0.0/24, and the other 2 PCs that you've actually plugged into the network live on 10.0.0.0/24. Let's say this PC has .1, this PC has .2, and then this PC has .1, this PC has .2, and they're all inside VLAN 10. Now, this is something you want to avoid. And the reason you want to avoid it is because this does not mean that 192.168.0.0/24 can now communicate with 10.0.0.0/24. That's not the case here. It still needs to go through a layer 3 device, which is a router, in order to reach the destination. What this does mean though is any traffic, let's say this PC sends out an ARP looking for the MAC address of this PC, that ARP will be flooded towards these 2 devices. Obviously they won't do anything with it because they're on a different subnet. But the idea here is to thoroughly understand that a subnet doesn't necessarily mean a broadcast domain, but 99% of the time it does. And there are some very, very corner case designs that you'll come across where, for whatever reason, you have 2 different subnets inside the same VLAN. But way beyond the CCNA, what I want you to really understand is just the differences between what a broadcast domain is versus a subnet versus a VLAN. Depending on design, you could span VLANs across the campus. Something we spoke about earlier, we said that there was 2 switches and they were connected together, and this connection between the 2 switches had a special name called a trunk, something we'll get into later. But this trunk allows us to trunk multiple VLANs. So across this link, we would actually have VLAN 5 and VLAN 6, along with any other VLANs that this switch actually has configured. And what it does is it allows us to put devices on this switch inside the VLAN. So if we had a PC in VLAN 5, which is the red VLAN, when a ARP message from this PC goes out onto the wire, it will actually be sent across this trunk to the switch and down to any PCs that are also inside this VLAN 5. And this depends on the design of the VLANs that we have set up. But this helps us get around that limitation that we had around the physical location of individual employees across the network. Lastly, something called QoS. With the ability of breaking up these VLANs, we'll find out a bit later that this link towards our router, in order for our router to understand that this is VLAN 6 and this is VLAN 5, the actual Ethernet header has a marking, and we can use part of that marking to actually set up what we call QoS, which is quality of service. And the idea here is, let's say we had another VLAN, let's say VLAN 10, and inside VLAN 10 we had things like our voice. What we can do is we can ensure that as traffic for VLAN 10 reaches the router sees the tag to identify it as VLAN 10, and in turn is able to apply some sort of quality of service. And quality of service allows us to ensure that our important traffic is routed first across the network and in turn reaches our destination with minimal disruptions. Okay, so that's all we've got time for in this lesson. Just going to go over what we've talked about. We had a look at the VLAN overview. We looked at some of the problems that we had with not having VLANs, around the expense of having multiple switches and not able to logically break them up for different departments. The challenges with physical location planning, if people wanted to move from one switch to another switch but maintain their security access. We looked into the lack of security features at layer 2 and how we can actually resolve this by implementing VLANs, as it's much better practice to have security between layer 3 devices, and as such we wanted to ideally have people inside their own subnets. We then dived into how VLANs solve those problems. We said the VLANs allows us to break up the physical switch into multiple broadcast domains. So one broadcast domain equals one VLAN. And then inside that VLAN, you could have multiple subnets, but 99% of the time, you would simply have one subnet. We said it improves the security because now, even though they're connected to the same physical switch, you could assign them different VLANs and different subnets, and you could actually have VLANs span across multiple switches to help moving and changing between switches much easier. It allowed us to have some sort of quality of service, where as the packets are now actually using VLAN tagging, we have an extra bit inside the tag to use to highlight the priority of particular traffic. And lastly, I just want to thank you for viewing, and I hope this video has been informative. If it has been, please do like and subscribe.